Video on how to transform a combination of imaginary and real numbers from the rectangular form into the polar form. So let's just jump into the example. Oh, by the way, this is actually more important when we want to analyze electrical analysis, usually in AC analysis, which actually involves a lot of combinations of imaginary and real numbers. So when we could transform the rectangular form into the polar form or vice versa, it will make us solve the problem more easier. So let's just jump into the example. Suppose we have a rectangular form of 3 minus 3i, and we want to change this form, which is known as the rectangular form, into the polar form. So first, in this rectangular form, we have two parts. First is what we call the real part, and second is what we call as the imaginary part, where it contains I, but the imaginary part only minus 3 is the imaginary part, not minus 3i. After knowing these two parts, then we must also understand what is the polar form. The polar form is just simply r exponent j theta, where j can be exchanged with I, but usually in most engineering cases we use j so we don't mix it, the I, which symbolizes for current. As I mentioned before, we will use these kinds of forms when we want to analyze AC analysis in electrical circuit problems. So we know R, and so R is actually the modulus, which I will explain later, and theta is called the argument. So from the rectangular form, we could actually draw a diagram, a Cartesian diagram, like when we draw the x and y axis, but instead of x and y, we write real and imaginary. Oops, sorry. Since we know that 3 is the real part, so we have a point over here, and minus 3 is the negative part, I mean the imaginary part. So from these 2 points, we could easily analyze the modulus, which I will draw the green line over here. Oops, has not changed color yet. So the green line over here is what we call the modulus. So you might be looking at the picture and you might recognize something, as this is a right angle triangle over here. So we could easily analyze the modulus by using Pythagorean theorem with the length of minus 3, size of the triangle with minus 3 and 3. So modulus R is equal to the square root of 3 squared plus minus 3 squared, which is equal to 3 to the square root of 2. So we have our modulus. So what we need next is the argument. The argument is simply the angle theta over here. We could actually analyze theta or the argument by using this larger angle, but in most cases we use the smaller angle. So we could find theta by using trigonometric ratios, by seeing that the known sides of this triangle is the opposite side and the adjacent side. So we know the opposite and we know the adjacent side. We could easily analyze theta by using the ratio of tangent. So by using Arcus tangent, we could evaluate theta. So theta equals to inverse tangent of -3/3, which is equal to -1. And by banging in your numbers into your calculator or using your trigonometric table, you could analyze theta is equal to -45 degrees, which symbolizes, the minus sign symbolizes it is in the fourth quadrant right here. So writing it in the radian form, this equals to -1/4 pi radian. So we have our theta and we have our modulus. We could rewrite our rectangular form into the polar form. So polar form is equal to 3 square root of 2 exponent j -1/4 pi. So that's how you change the combination of imaginary and real numbers from the polar form, from the rectangular form into the polar form. So I hope this video helps a lot. Give your comments and don't forget to subscribe and like the video for more videos in tutoring and learning other types of subjects. You could also type in any questions you like in the comment box below, so I could actually read them and give some tutor about it. So see you next time.